Hello, everyone, and welcome to Handmade Hero, the show we code a complete game live on stream. Uh, and you know, one of the things I always say is no engines, no libraries, because we're not really allowed to use any of those. But one of the things that's kind of annoying is that since we are programming in C, we call the C standard library for some things, and that's not necessarily something that we want to keep doing. So at some point, we'd like to remove even the C runtime library so we can literally be at, absolutely zero libraries, except those that, are actually just calling into the operating system, like stuff that we literally can't not do because, if you want to run a game on Windows, well, you got to ask Windows to open a window for you because it's Windows, right? So we're kind of at that point where it's like, all right, maybe we got to take the time soon to actually go replace the few C runtime library functions we're actually using, which is like a couple of math functions and like a string formatting. Because in our debug system, we were actually using the string formatting to print stuff out. And so, it's like, not sure exactly what the timing of that needs to be. So I've been thinking about it, and I think what I'd like to do is today, since we're kind of in the middle of doing historical debug stuff, I think what I'd like to do today is do a little bit of work with the historical debug stuff and kind of get that to an interesting place where we're kind of using it a little bit. And then next week, we might go ahead and do actually replacing our C runtime library stuff. We'll just go ahead and go, all right, let's get the C runtime library out of there. Let's build the utility functions that we actually need. Because since the debug stuff is kind of calling into that as part of the formatting we'll do a little print formatting for formatting our values, and then we'll just clean up the couple I don't know what we've got in there for flooring functions and sine and cosine and maybe atan2. I don't know what all the ones are we actually need, but basically just some math library functions and then the string formatting. And that's all, we don't use anything else from the C runtime library, so it's actually pretty minimal. But we've got to replace it at some point. And that seems like probably a pretty good time to do that. All right, so let's go ahead and get started. Today is day 180. And day 179 source code is obviously what I'm starting with today. So if you would like to follow along, unpack day 179 source code, that is where I am at. So I'm going to go ahead and load this up here. Let's go ahead and load up handmade.sln. And you can see where we left things off. You can see that we've got a little debug, sort of a debug output situation going on here, right? Where this was kind of the thing we were working on. We've got these pretty free cycle counters that we can drop in there now. And it tells us what's going on. And in fact, even just from this slight amount of additional debug code, you can now see when ground chunks are getting filled and stuff like that, right? We're actually seeing information that before we wouldn't have known, right? We would not have known anything about when these ground chunks were being filled, and now we know, right? And so we're already kind of getting a better picture of how our program works. But like I said on the previous stream, it's still kind of hard to use. It gives us a little bit more insight, but it's not as much as we would like. And we did the work yesterday of figuring out how to keep these things tracked over time. And in fact, what we're displaying here are actually the running averages, not the absolute, the one on any particular frame. So we're on our way to having sort of a much more instructive thing to view here. So what I'd like to do is I'd like to go ahead and follow that down a little bit, just keep going a little bit further on that, and maybe start to make use of those values so we can sort of see maybe a little bit of for lack of a term, maybe a little bit of a graph over here or something so we could see spikes, and maybe play around with some other sorts of things that we would like to see. So really just kind of start to take a look at what could we do to make this a little bit more useful. Now that we've done the work of storing it properly, how can we actually display it in a useful way, right? So let's go ahead and open ourselves up. And we made a handmade debug.h where we put this stuff. Here it is. But we kind of only have the very beginnings of something to output this information, right? We update it here, and actually, we could do something interesting here. We could move, we could just move this stuff out. In fact, debug record array counter, that's the only one that needs to be declared there. So we could, in theory, move this guy. We could move this guy out. So we could start to actually put them in the correct place, right? Yeah. So what we would need to do here is we need to start including our handmade debug.cpp somewhere, right? So we need to go in here and start including that. And then we can start putting the debug code in there so it's not clogging up our main file and getting us confused about what is like the debug code and what is not, right? So I'm going to go ahead and put that up at the top, potentially. I don't know where that wants to be. We can deal with that later. But here we go. So in here, this is our debug update. We've also got some stuff where we would want to actually draw. So our drawing code, that should probably be separated out into the debug stuff as well. And that is all this stuff, right? This is the stuff that we were working on with debug text line and these globals and kanji owl code points, of course. Who can forget kanji owl code points? And I'm just going to go ahead and grab this stuff and move it over so we can sort of start to talk about this and look at it, you know, in a more concrete way. All right, so I'm going to grab this stuff and put it over here. We've got this standard I/O. This was the thing I was talking about earlier. I'm like, it would be nice to remove this. And you can kind of see that, you know, the reason we were using it is because we have to format some debug information. So I'm going to put that up at the top here. And you know, that's the thing that I was thinking maybe next week we should tackle so that we don't rely on the C runtime library. Because again, if you're not using any libraries, you might as well go whole hog, right? Like, why use the library that's built into the language? If you're trying to use no libraries, you might as well not use any at all. And we can just be, even though it's the C runtime library and it's like sort of built in, it actually isn't like required to be built in. We actually will probably be able to turn it off, like even on the build line, so that it just never even gets linked into our program, which is kind of cool. So, you know, even though it's like, in theory, part of the language, it's really just a lib that gets linked in just like every other lib, so you can actually turn it off, which is pretty cool. It's not like, you know, in some languages where it might be like so welded in there where you literally can't, I mean, you could not call it, but it's there. It's like in C, if we don't call it, we can actually turn it off completely, so that's kind of nice. All right, so let's take a look here at what we're doing. Right now, I made a thing here which sort of creates the averages over time for these things. And, you know, what I'd like to do is maybe just draw a graph of the actual values over time, something like that. So I'm going to, you know, right now we don't really have much in the way of good utilities for this. But I'm just going to try pushing this through the renderer as something where I can just draw like a bunch of little rectangles where the height of the rectangle maybe is the kind of cost of that function over time, something like that, right? Hopefully that makes some sense. So for each counter, when I go through here and I do the snapshot index, and you know what else? The other thing I want to do, I don't know that I like the idea of these things kind of going away. I think I might want them always. So I think what I'm going to do is, even when something isn't being used, you know what? I might also just go ahead and have that, you know, kind of continue to print out. All right, so it looks like, yeah, since this the debug stuff wants to be able to access the render, I'm going to go ahead and do that. The asset system, I should say. I'm going to go ahead and put it back down at the bottom. Okay, so, yeah, in here, that should mean that everything, you know, all the debug counters that we have, so now we can see, like, actually all of them. Even when they're at 0, they'll show up here. And that way, it'll be, like, stable, and we can see the charts over time and stuff like that. That's the only reason I'm thinking that. All right, so if I want to do that, how would I do that? How do I draw this information? Well, you know, I'm trying to draw a graph here, and obviously these values kind of have wildly different sort of heights. They have wildly different maximum values, right? Because, like, let's say I'm talking about drawing the cycle count the total cycle count spent in something, well, the total cycle count spent in something is going to be drastically different from like if it's some core render routine versus some like function that hardly got called at all, right? And that isn't expensive. So just having some fixed scale is not going to be really that useful. So I think what I'll do instead, right, is I will take whatever the maximum value is, because remember, I have the maximum of the cycle count, right? I have the maximum cycle count for whatever counter I'm on, right? After I do these snapshots, I know what that is. So what I could do is I could say, oh, all right, you know, let me run through the snapshots again, grab the cycle count out. So now I know what that cycle count is supposed to be. And I could divide that by whatever the maximum cycle count is, right? So I could just say, oh, okay, you know, assuming the maximum cycle count is greater than 0, then I can always take whatever the cycle count was that we have. I could divide it by like the scale, right? So the scale is just going to be the inverse of the cycle count, like so. So this would just be scale times, right? So if I want to do that, I can say, all right, I have the cycle count. I scale it so that it will now be between 0 and 1, right? Because even if it was the maximum cycle count ever seen throughout all the snapshots, you know, it'll go. It would. It would only hit 1. So now I can just say, well, whatever the height is that I want the chart to be, I can multiply this value out, right, by that. So I can just do, well, and you know what? I could just even bake that into the scale itself, right? I can just have chart height divided by cycle count. That's going to be the scale, right? And that'll map any value in the cycle counts that we've seen to the height. Now there's something that we'll see when I sort of get this working. There's something that we'll see that's possibly undesirable about what I'm doing here. But I'd rather kind of show it to you first, and then we can kind of decide what to do about it rather than sort of pre-solve the problem. So, okay. And maybe we'll decide it's not a problem. There's also that. So if I go through here and we do this sort of scaling operation, right? We now have the height that any given snapshot of the cycle count, how high that should be for our chart, right? So this is going to be, this height. And so what we want to do here is we want to draw a rectangle or something, right? We want to do a rectangle draw. So I'm going to take a look at our render group. We still have like the ability to push a rectangle, right? So if I do a push rect here, if I do a push rect, I should be able to just draw, for every snapshot, I should be able to draw like a little bar, right? So it's kind of like a little bar graph going across, and I just draw 1 pixel per snapshot. And then since there's, I think we said 120 snapshots, something like that, it has to be a 120 pixel wide graph of stuff, right? So again, really, really simple. We have this sort of concept of debug render stuff. And so what I'd like to do is actually, the debug text thing, right? This debug text line thing. You can sort of see on here that we have a way of drawing a debug text line, and what it does is it kind of queues up into that render group. It queues up whatever it was that we were going to do for that rectangle. So I don't know, we could do something like that, or we could just go ahead and push it directly. I don't know which one we want to do. But I suppose we probably want to do something like this, where we'd say, you know what, let's make sure that we have both of these, because if we don't have a debug render group, there's no point in doing any of this display stuff. And then what we could do from there is just push rectangles directly onto that render group. Because we know that render group's already in screen space and everything, so it's going to be really, really convenient, right? So in order to do that, we would want to probably do that after we print the text, right? So here's the text. And then we know as well that the text itself, if we wanted to put it next to the text, one problem with this is the text line is going to kind of advance itself down. And so actually, I guess now I think about it, we almost, until we get a better like layout system in here, which is something we probably want to do, I guess I want to do it kind of beforehand so I can sort of fake read out of the text stuff. I can figure out like where this stuff actually is in terms of lines so that it'll line up, right? So wherever that baseline for the text is, that's what I actually want to know. So this at y, right? I want to know the at y because the at y, you know, this basically tells me the information that I want, right? This is the stuff that's going to be relevant to this chart. So you know the chart min y and the chart max y, or I guess I could even say just the chart height. The chart height should probably be the size of a line of text, right? And then the chart min y should probably be where the baseline of the text is, or something like that. Seems reasonable. And get line advance for is maybe not the most reasonable thing, because, you know, if you think about it, the line advance is the whole line. I think I probably want more like the ascender. I probably want something more like this. So I suspect what I want is like the ascender height should be the chart height. Something like that, I would suspect is a little more correct. Yeah. The problem, of course, that I have is I don't actually have the font information at the moment. So that's something that, yeah, we would need to be able to grab out of that debug text line thing as well. And you can sort of start to see here, I don't know if you get this little tingling sensation, but you kind of start to see here that, like, okay, you can imagine how this stuff is going to start to collapse down a little. Like, look at all this code. You know, there's way too much of this nonsense going on here, right? Like, you could imagine me doing this stuff. Well, that stuff all just seems a little too boilerplatey, and like, if we're going to make a debug system where it's easy to print out stuff, we don't want to be like querying the font all over the place and stuff. So, you know, just kind of put that, in fact, I'll even put it to do here, layout, cached, font, info, etc. For real debug display. You know, that's something that we're going to want to sort of push into going forwards, just to get a little bit better stuff happening there. All right, so here we are down here now, and we actually would have that font info. So now we know the ascender height, and we can figure out how high the chart should be. So when we go to push the rectangle on, we now have the ability to actually draw something. I don't know. I guess I'll draw something for the moment that is yellow, maybe. You know, maybe I'll even do something. Maybe I'll do something slightly different. Maybe I'll even do this, and then put the chart height in there. So this proportion, we'll do graph times scale. There we go. And this way, I have a number between 0 and 1 that is how much of towards the maximum this particular sample took. And I'll just shove that into the red channel, and that way we'll get sort of a, you know, we'll get yellow when it's at the max, and green when it's at the, you know, when it's at the min. Who knows why, just because. And so then for setting the offset and the dimensions for this thing, right, are going to be like whatever the height is in y. And I don't know how our rectangle routine, we wrote it so long ago, is probably a little janky, so we're going to have to play with that a little bit, and maybe actually go make sure our rectangle routine is you know, usable and is accurate enough to do, you know, per pixel stuff, because it was one of the first things we wrote and probably isn't. But anyway, so in order to figure out where this thing actually goes, we need, like, you know, whatever the chart left is plus the snapshot index, right? That's going to be the location we want to do in y. Then we've got our chart min y, and then our z, I think we don't really need anything for. And that should in theory do it, assuming that's in pixel space, I assume. So we need a chart left, and we don't really have any idea what that would be at the moment, so I'm just going to hard code that in at the moment. And we'll have to sort of, again, this is one of the things we're talking about when we talk about layout. We probably want to start thinking about how to lay things out so we can have text and charts and stuff embedded and have them sort of all play nicely together. But just for starters, for getting things working, let's start working with this and get something actually usable first, and then we can go kind of try to get a little fancier, right? All right. So I don't know what this is going to do. Let's see here. Oh, okay. So it looks like, you know, we've kind of got like heartbeat graphs at this point, it would appear. And so the dimensions, our rectangular routine, it looks like it takes the center and goes out from there, which is actually fine for the graph, but it also means it doesn't quite line up with where things are. You know what I mean? So that's not, you know, that's not possibly the best. That's not necessarily the best idea. So there's that. But we could fix that pretty easily. So maybe we can go ahead. Maybe we go ahead and fix that just really quickly. So assuming that the rectangle is being drawn at the center, then what we would need to do is we would need to make the dimension still stays the same, right? But we need to offset the min so that instead of being at the baseline, it's actually up by half the height, right? Yeah, like so. And that's you know, that's going to be more sane. So now the stuff looks more like a proper bar chart, right? And lines up a little bit more properly with the actual lines to which they correspond. Now, I don't know how accurately, so let's go ahead and just double check here with kind of use a little ruler. Yeah, so that looks right. So I think we've got that under control. And that's all good. So, okay, so now we've got the ability to draw little charts on the side. And what you'll notice, so the thing that there's a lot of things to talk about now, but one thing that you'll notice is these charts, they change their scale, right? They oftentimes will change their scale. And the reason that they change their scale is because they're using whatever the maximum value was for the past, you know, 120 cycles, 120 frames. And what that means is that in the case where there's some kind of a performance spike, like perhaps due to like the operating system taking some time at that particular moment in the code or something like this, or, you know, who knows what happens, then, you know, if there's a performance spike, that will reset the scale of the graph for that 120 frames. But as soon as that performance spike falls out of the 120 frame window, the scale will jump back up again. You know what I mean? So that's why I was saying there's a little bit of jankiness to how this is done. The problem, of course, is it's not really obvious how you really want to do this sort of thing, right? You know, I suspect that if I sat down for a long time and thought about how to visualize the graphs as you know, perfectly as possible, we could come up with some rules, and they might be stuff like, okay, like filter out outliers and just mark those specially, and then otherwise use the average and blah, blah, blah. But there's just all these concerns there. Like, you also can't compare the graphs to each other the way that they're here, because, you know, I can't tell, because the scale is varying, I can't tell if this, you know, versus this, who's taking more time. So there's just, you know, there's a ton of things like that that are reasons why this is not probably the most fabulous possible thing that you could do in the world in terms of visualizing data. But at least you can now see that we're, you know, properly recording the debug data and that we can view it over time. Okay, and we could also say that, you know, we can make this like bar width. You know, we could make it so, since we've got room, it could actually be like 4 pixels per or something like that. So if we wanted to, we could make this be bar width, and then we'd do like the snapshot index times the bar width to move it over. And we'd, of course, you know, always subtract away half the bar width because that's the... actually, I guess we would add half the... Well, you know what? It doesn't matter. We don't care where we're... Well, we would add it... If we wanted to line up with the left edge, which we probably would want to do for layout purposes, we'd have to add half the bar width, right? So there's some, like, you know, a little bit fatter, right? A little bit fatter bar graphs, just which are, you know, maybe a little easier to see. And, you know, and off you go. And so then you can kind of see the heartbeat going there. And it's kind of entertaining, if nothing else. And you can totally see the usage spikes as well. right? Like you can see where the performance spikes are. They're pretty clear. So, you know, like what was that right there? Who knows? And so yeah, I assume, I don't really know, but I assume that those are things that we couldn't really even track down and fix necessarily. That might just be the sort of the vagaries of trying to run something where you're on a machine that's running like open broadcasting system in the background. Not sure. But to say the least, it's probably not the case that in general we're actually getting like a spike that's happening because we happen to call, you know, begin sim in a more expensive way on one particular time. That's, you know, that's probably not the truth. But who knows? Until we actually literally go investigate, it's hard to say. So, all right, that's, you know, that's fairly interesting. But what I'd like to do now is I'd like to kind of start looking at this in a more holistic way. You know what's kind of interesting too? It's worth pointing out here. So do you see these nulls here, right? Those nulls are anywhere where we've never actually hit the performance counter. Because if you remember, the only time that the performance counter actually knows who actually is using that slot is if it actually gets called at least once. So unfortunately, we'll never actually see the name show up here until it actually gets called once. So once I start doing some stuff, right, and we actually get to, you know, those, if we ever do actually get to whatever that thing was timing, then we can actually see what the performance counter there was. But until then, we have no idea, right? And that's just the nature of the way that we built the system, because since we want it to be very easy to drop stuff in, part of that was that you only put code in just the one line, you know, where the function is. It says, hey, let's put the function in here, right? And so we could decide not to display those functions, because then, you know, yeah, it would be a little unstable as things get added occasionally, but otherwise it would be, they'll never go away. So what we could do is replace, when we were doing our if, where we decided, you know, whether to draw debug out for something in particular, what we could do there is say, all right, let's go ahead and test on a counter. If it's got a function name, then we'll assume that it was actually filled in at least once, right? And then that way we'll only see functions that we actually have called at least one time, so that their information is properly filled. Okay? So again, pretty simple. So now what I'd like to do is I'd like to go ahead and sort of take that concept a little bit further here. What I'd like to do is make a sort of a stacked graph of some kind. Something that kind of shows me over time who is taking, you know, what time and in sort of a little more proportional way. So what I want to do is the first thing I'm going to do is I'm going to go into that debug sort of the debug info, that watermarking thing. Remember I made this where the platform layer passes in sort of as the stuff goes, like, what was the time when the executable was ready? What was the time when the input was processed? What was the time when the game finished updating? What was the time when the audio finished updating? What was the time when the frame rate was done? And when did the frame actually, you know, loop back around to the top? What I'd like to do is just save that as well as a separate set of snapshots, right? So inside Handmade debug.h, where we do these sort of snapshots, what I want to do is make another one of those that's just sort of outside, which is like frame end infos. And that's just going to store all, you know, the same sort of deal, right? It's going to store a snapshot, one for every frame. And so then what I'll do is whenever we actually get that strobe event at the end, and we actually do sort of our debug update, that I want to save a copy of that info that comes in. So the other thing that I'm going to do here, right, is I feel like, well, I don't know. I'd like to have this be in here, but it's pretty hard for that to actually be true. Well, yeah, what I could do is I could just put this stuff at the bottom of the Handmade debug thing, I suppose, right? I could do something, I suppose I could do something like this. I don't know if you think this is a good idea. You might not, and you might be right, but I'm going to try it anyway. And so I'm going to come through here and grab Handmade Debug. I'm going to go ahead and put that here. All right. And then what I will do is I'll just move the stuff that we actually kind of need to move out into the H file. And there's some stuff in there that we want to take care of separately anyway, some stuff that's like some global variables that we don't really want to really be actually all that global. So yeah, so let's see here. Render group is struct render group. We'll just forward declare that, no problem. Font ID. That one doesn't really need to be there. In fact, it's probably only that one that really needs to be there. So these guys can stay here for now. But we probably want to take care of those in a slightly different way, longer term anyway. So debug reset would have to be actually put in there. And debug reset, I feel like debug reset could almost happen during the strobe as well. Well, I'm not going to fuss with it at the moment. But we maybe want to consolidate that as well either. There's the problem, it has to pass the buffer information in. So, you know, maybe it makes some sense to actually do it there. But either way, I'm going to go ahead and put it out here so it can be called. And game asset structure needs to be pre-declared as well. And lastly, overlay cycle counters. So this, I don't think we actually want to call this overlay cycle counters. What we actually want to call this is, you know, overlay debug, or like debug overlay, right? Because that's really, you know, that's really what that is. And so we'll call debug overlay here. We'll put that in. So overlay debug count. Oops. Where is that? Oh, yeah, that is it. Overlay sub counters. So we'll call this debug overlay, and that will do all of our debug overlay stuff. And that can just live in here. And then we'll see how we do. Okay. And so that should have done absolutely nothing, right? Now we should just be back where we started, but ready to kind of do a little bit more with it. All right, so if I come into debug overlay, well, let me first save the information. If I come into debug frame end, if I want to do the snapshot capture, right, I can go ahead and say the debug state, we've now made the frame end infos. That snapshot is just going to be equal to whatever the info thing is that I got that I got passed, right? So now we have a set of those that we can actually, you know, go back through and draw. So in here, when we do our, when we do our counter display, after we do all of the counter displays, we could then also put some in here where we draw all of the debug infos that we've been passed. So here, like so. There we go. So now we've got these frame end infos. And that's just going to be whichever one is the snapshot that we're on. And what I'd like to do is I'd like to draw that in sort of the same way that I was drawing the other thing, but because it's got multiple pieces of information in it, right? What I'd like to do is I'd like to make that be a little clearer. And you know what I just realized too? There's something we could do here that's kind of cool, because I was thinking about this before. You know, oh, yeah. Yeah. I like this. So I was thinking about this before, and if you take a look at what happens here, this debug frame end info thing, if you think about what's going to happen in terms of platform porting, this is kind of specific to the Win32 platform layer, right? We kind of, the order in which these go, the order in which these sort of strobe points go, is very much specific to the Win32 platform layer. And that's not necessarily something that we want, right? That's not necessarily a particularly good way to do things, especially because it means that now, like, if some other platform layer doesn't do things in the same order or doesn't do the same series of steps, this is kind of the wrong, it's the wrong abstraction for it, right? So, a better thing to do here probably would be to have the debug frame and info be something that was more like, well, maybe something more like there's a debug frame or a debug frame timestamp, and it's just like something like this, right? Where it's like, what's the name of this particular timestamp, and what's the clock at that point, right? This is the seconds. And then what we could do when we pass this thing in, is we could do U32 count, right, and debug frame timestamp. Like that. I don't know if timestamp is timestamp or timestamp. Doesn't really matter. And so that way you just get some timestamps, you just get a certain number of them, and you would know that that's how many you have total, right? And I suppose one thing I could do is I could also maybe do it more like this, where it does still get this piece of information, but that information actually has these in it, right? So I could do like timestamp count and debug frame timestamp, timestamps, something like that. I could do that, and then just have these guys, are all in there. And this is some known size thing, so it doesn't have to actually, it could just be passed as a struct, or it can be an address thing, I don't know. But we know we're not going to have that many of them anyway, so we could just have that be fixed. It doesn't matter. That's entirely up, we can play with that later. So if we did something like that, then this guy could just print those guys out as a stacked graph as well. And then we could also have a thing in here which was like, for the debug frame timestamp thing, we could have the timestamp count and an R32, which is like total seconds. So like what the actual amount of time believed to have been taken on that frame was, and then where all the timestamps were sort of along the way, right? And so if I did that, then what we do here is say, all right, here is however big that chart thing is going to be. I don't know how big that's going to be, but I want it, I think, probably to be pretty high. So let's say it's something like 300 pixels tall or something like that, Assuming that it's 300 pixels tall, as I go through here, what I'm going to want to do is make a set of stacked bars that kind of go up. And you know what? Kind of layering all these things I want to do on here. The other thing I'd like to do is, I don't want to have to keep doing a rectangle. I don't want to have to keep doing rectangles that are about centering. I want to be able to do rectangles where I put the min and max corner in, because that's just a lot more convenient, right? That's a lot nicer. So we should probably make one of those as well. But anyway, let me just sketch out what I'm going to do here, and then I'll kind of go through and fix everything that I just said that I wanted to have happen that's not happening yet. And since I'm the only one here, I'm going to have to be the one to do it. So if we do this, what I would want to do is, for this info, I want to go through the timestamps, right? And I guess I've got, right, I have a scale, and like before, and the scale is going to be the chart height divided by the total seconds for that frame, right? So for any given frame, well, actually, you know what? This is not even true, because this is, since I want this to actually show me how long each frame take for real, for reals. What I'd rather do is say that the total chart height is going to be like, maybe, let's say that the total chart height is something like 60 milliseconds or something like this. Like, suppose a really bad frame time. So we've got 1,000 milliseconds, in a second, right? And so if we were going to run at like something really awful, like 10 frames a second, right? We'd have 100 milliseconds taken up in a frame. And so I'm going to make the chart height be absolute. So it's 100 milliseconds. And so if somehow we started running that, if somehow we started running even worse than that, we would actually pop out through the top of the graph. And in fact, maybe since since our goal frame time, since we don't care, if we miss 30 frames a second, we're just unhappy. Maybe what I'll do is say instead, let's just do it at 33. So we'll basically say like 33 milliseconds is our target, and so we'll actually pop out of the graph if we're not actually hitting that, something like this, right? So what I would say there is like, okay, 33 milliseconds is going to be what we want, and so in seconds, right? 33 milliseconds is that, right? It's like that. So yeah. So that's how much time we would actually want to spend in order to keep hitting 30 frames a second. And so let's see what we need to do that, right? So that's our scale that converts seconds to the chart height. Here's our info. And now I want to draw a stacked graph. So what I want to do is say we've got exactly this same thing happening here, and so we would have sort of the proportions. This would be exactly the same thing. And I guess again I could do sort of the proportion bit where we color coded. If I wanted to do the exact same thing, I could do that as well, right? So that we multiplied the chart height out in here. So I could do literally this exact same thing, and only this time, instead of any sort of cycle counts or anything like that, what I'm doing is actually going through the timestamps here, right? So I have my timestamp index, and I'm going to go through the timestamp index for a particular frame, which is this. And for each one of those, and I really want to capitalize that, don't I? For each one of those, I'm going to get out the debug frame timestamp, like so. And I'm going to grab that out of the info structure. Once I have that, I'm really just interested in this total seconds bit here. Now, there's something that's a little bit tricky. And that is, these things are timestamps based off of a base counter, right? So I can't just draw what proportion the actual timestamp would be. I have to draw what proportion the timestamp minus whatever the previous timestamp was, right? So I have to know what the previous timestamp is, because these are like timestamps, not measured amounts of time. And so what I want to do for this sort of a situation is I want to take the previous I want to take whatever this is like previous timestamp seconds, whatever the previous timestamp was. So this seconds elapsed basically is going to be the timestamps seconds minus whatever the previous timestamp seconds was, and then yeah. I mean, that's really all there is to it. And then the prev timestamp seconds is going to be whatever this guy was. So we're just kind of keeping the spans coming out. So this seconds elapsed. That's going to be gone by the scale to figure out how it comes into the chart. Then we're going to do the chart height. And then we're going to do the same exact stuff here to draw it. The only difference is now we're going to draw them stacked on top of each other instead, right? So in order to do that, again, this all has to be essentially the same. So all of this is exactly the same. Only now the chart left, since this is kind of going underneath everything, this could actually be whatever the actual leftmost edge is of the debug stuff, which I believe we actually store in here somewhere, right? Left edge. So we can just start at the left edge of the screen if we want to. Maybe we'll go in by 10 pixels for good measure or something like that. But basically otherwise the same. We could then say that our chart bottom is going to be wherever we were in @y plus the chart height. Again, maybe plus 10 pixels for good measures to move it down a little bit. And so then this stuff I think should all be the same. The bar width, I don't know if the bar width should be maybe made fairly large. I'm not sure. That's a really good question. But we could also do bar spacing. So we could make it so that the bars were visibly distinct, right? We could do something like this. And so if we did that, then we have bar spacing here. We have bar width here. And again, I'm not going to worry too much about the centering at the moment, because I'd like to do something. I'd like to change the way these rectangles are rendered relatively soon. Okay, so the bar width is the bar width. This height is this height. That's all right. This proportion's fine. And then this is chart min y. So, whoops, chart min y. Okay. So I think, and this bar spacing plus the bar width, it's actually it's plus 5. Yeah, I don't know what I was doing there. I want to fix this stuff because I don't want to specify these this way. So all right, so that'll draw the rectangles for us. And so I think that's roughly, that's almost what we want. The only problem is we're now, we don't actually have, oops, debug frame and info. We don't actually keep track of the stuff this way, right? And total, I don't know, maybe we don't need total seconds. Maybe the last guy kind of tells you what the total seconds is. I don't know. Doesn't really matter. So let's see here. So in here, now in our frame and info, we're actually going to do something slightly different. We're going to sort of have a little macro, I guess, or something that just adds on to this. It doesn't really even need to be a macro, I suppose, at some level. It could just be an inline here that's like, void take timestamp or record timestamp, something like that. Right? And this thing is just going to take one of these debug and frame and info things, and it'll just record whatever the time is right now. Right? It'll just insert a thing that records a timestamp in right now, and I'll do whatever the name is. And so that'll just do debug frame timestamp. First I'll assert, obviously, that my info timestamp count is less than however many there actually are to use. And then I'll just say that the actual one I'm going to use, timestamp, is that one. I then just record the information here, and I can put in that win32 wall clock, whatever the wall clock thing is, right? Win32. I might have to make this a macro because I guess I don't know win32 get wall clock. I don't actually know win32 seconds elapsed. Win32 get wall clock. I don't actually know how to do the seconds elapsed if I don't have what the last counter value was, right? So I guess I do want this to be more of a macro so that it can be placed in there. Although I could just do it this way, where you actually just pass the seconds in, and that's fine too, something like that, right? Okay. So let's see here. Win32 record timestamp. And so in here, I would just do whatever that debug info thing is, frame end info. I would just do the same exact thing I was doing, but now I just pass executable ready as a string, right? Like so. Hopefully that makes some sense. So let's just do that for everybody. So there's input processed. Again, pass it as a string. Save that. Next one down. Whoop. That's going to be game updated. Again, not doing anything interesting here, just literally doing the mechanical process of converting these timestamps. I hate the way, I wish I had a, like, when I kill something in Emacs, like, I don't want to actually lose what was in my paste buffer. And there actually are some ways to do it, and I fiddled with it, and I never got the elisp to work right. It was making me grumpy. Mr. Fourth Dimension, if you're out there, Alan, if you can solve that problem in your editor, it'd be pretty sweet. It's just, you see what it is. It's like, I used cut and paste to remove something, and then it loses this thing that I wanted. And I want that, like, I think Emacs has these, like, register things for it. I don't know. It's just always kind of clumsy, and I don't... I just want a nice, like, easy-to-use thing that makes that work okay, right? So, yeah. Okay. Let's see here. And then end of frame. So that's the, like, total seconds. would also be that value, right? So that's going to be here. End of frame. Yeah, and I guess that I don't really need that total seconds there. Or maybe I just don't put the marker in there. I'm not sure. I'm not sure which one of those things I should do. Right? It's a little confusing. I guess for now what I'll do is I just won't put the total seconds in there. That's what I'll do for now. And we'll see. Maybe that's good, maybe it's not. All right, we've got some issues, to say the least. That is not where my chart should be showing up. So let's go fix that. Let's see if we can improve that just a little bit. So there's my chart min with the half this height. So that actually seems okay. So what's the oh, because that's supposed to go down by the chart height. That's the problem. I went the wrong direction. Always, you know, I'll never unlearn the fact that y goes down in programming for some reason. You know, that's I guess just in the old days I'm just so used to it that it's really hard for me to kind of like it's hard for me to switch into the y is up thing, even though that's the way math, you know, wants it to be and all that. So we gotta go. Why are we going higher? It looks like we're going higher than our 300. Oh, that's why. But it still looks like I'm kind of going up in there, and I shouldn't be, right? I should not be. Because I said that the chart height was 300. I should only be drawing up that high. No, I did it again. Seriously. WTF, right? That doesn't make any sense. Oh wait, no, that one's fine. That one's fine. Because the chart min y, it's gonna go down by that much. So that was fine. That was just me being overly hard on myself. It's fine. It's totally fine. So yeah, so why am I still overshooting there? Because I feel like that's a little bit odd. The chart min y should start at whatever the at y was for our text line, so all of our text lines are done. Then it moves down by whatever the chart height was plus 10, and presumably everyone is just doing that. I guess maybe we're missing, because of all this debug printout, maybe we're missing 30 frames a second. I don't know. We should probably draw where 30 frames a second actually is. So let's do that as well. Let's just go ahead and do a push rect on here for the 30-second bar, right? And so to do that, we just do chart left, and we do chart min plus chart height. So, and then our bar width is, you know, the width of the graph essentially. It's going to be chart width plus 0.5 times, you know, chart width, and that's chart width, chart height, and we'll just make that the 1.0, like the white line. And what we'd want to do, in fact, I guess I can put that down here as well. So what we'd want to do there is figure out what the chart width actually is total. And the chart width would just be the bar spacing times, times however many of these snapshots there are, right? That's how wide this thing will end up being. So that would at least give me where the top of the chart's supposed to be. Oh, and of course I probably only wanted to draw 1 pixel there. That's I was a little overzealous with that. So sorry about that. We'll, all right, so I guess it is in the right place, and we're missing our frame rate by a little, it would appear, which is probably not that surprising given the fact that we're dumping a bunch of this extra rendering onto the system. We're not even compiling in release mode, and it's, you know, got to draw all these rectangles, and our rectangle drawing routine is not optimized either, right? Our rectangle drawing routine is actually incorrect, right? Of course, it is a little weird. Yeah, I don't know. So we'll have to play around with this a little bit more. We're almost out of time for the stream. So the next thing that you know, the other thing that I wanted to do there was I just wanted to make it so that we could see those sort of see the individual rectangles a little bit better. So what I'm going to do is I'm going to go ahead and make it so that they're colored distinctly. I guess the proportional stuff is not so interesting in this, at least in this particular one. Yeah, so I'm going to go ahead and try to color these things, color code them, so that you can actually see the, you know, them stacked on top of each other. And so in order to do that, I'm just going to do something like colors, and I'm going to have the different colors in here. I'm just going to write them myself, right? And so what I'm going to do is I'm just going to do like, okay, for now, these are not particularly good colors. We can kind of fix them later. I guess I'll do V3. We'll do something like just, you know, primaries, secondaries, right? And then maybe like another set that's like half, with halfsies. Something like that. So let's see. So I want to do maybe 0.510. And then on the other side, like so. And then maybe 0.51. And actually do it here. And I'm just putting in like some colors, right? So we actually have just a set to work with. So what I want to do here is say, okay, whichever one of these timestamps it is, I'm going to grab that color. So we'll do the color here equals colors, you know, timestamped index mod array count colors. And then the color can just be, you know, v4 color 1. Does that make sense? And so when I draw this thing out, that does not look right at all. So I think we've got a bug in here, like somewhere, right? I feel like this feels a little bit buggy. This seconds elapsed is the timestamp seconds minus the previous timestamp seconds, and then the previous timestamp equals timestamp seconds. That should be sort of taking whatever that delta is. And I feel like if it's blue, it's just saying we're always seeing just the third one. Are we sure that this is actually working properly? This height equals short height this times this proportion. The proportion is going to be out of 33 milliseconds. Oh, I still haven't stacked them. I never actually bothered to stack them. So what we need to do here is we need to stack them up, right? I need to do a thing where I take like, you know, stack y, and I need to make that equal to what we were starting with, right? Like so. That's kind of obvious. And then after I stack it, I've got to add on whatever our actual height was for the guy, right? So there we go. That's more like what, you know, I was thinking. And so you can kind of see actually that, to no one's great surprise, we have one thing that's taking basically all of our time, and that's inside our game thing. So we're going to have to do a little more work to make this more useful, but you can sort of see what I'm starting to get at there, right? And eventually what we need to do is we need to go ahead and make this so that we can kind of break this up into stuff that's actually also in the game, possibly tied into this sort of stuff. But you can sort of see we're starting to get into the realm of something usable down there. But I'm out of time, so what I'm going to do here is I want to space this out a little bit more. So I'm going to have some spacing there. There we go. But we're getting there. Slowly but surely, we are getting there. And, you know, I feel like really the next step is to kind of unify these two things and maybe try to figure out a way to get the, you know, get the timestamps and the count blocks to be basically doing the same sort of stuff. I'm not sure I know exactly how I want to do that yet. It'll be an interesting challenge. All right, anyway, I'm going to go to the Q&A, or I'm going to try to go to the Q&A anyway. Let's see here. CD. I don't actually remember. Let's see here. There we go. Q&A. All right. So if you have any questions about what we did on today's stream, now would be a good time to ask it. Go ahead and please put Q:, in front of the question, and I will try to answer it. Questions? Not a lot of questions. In fact, I would actually go so far as to say that there are 0 questions. Hey man, it's a Friday, we can end early. Brain Cruiser, doesn't the multi-core rendering screw up your timing? I don't think so. I can't think of any reason why it would. We made sure our timers are multi-core safe. So like this stuff right now, these things are not so interesting because they just don't really time anything granular enough. I want to go ahead and tie these two systems together. I really probably should do that. But these timers are thread safe, as far as I know. We tried to design them to be so. So basically, even though there's a bunch of threads all running the same stuff at the same time, in theory, all of the counters just sum together and give us the right value back, in theory. Can you briefly explain how it tracks how long it takes the frame to work and the render engine to work if rendering the debug is part of that work? Also a suggestion, use the key to toggle the debug display to see the game. That, we're not at that point yet. So controlling the debug view is not, that's a separate topic for a separate day. It will not probably be keyboard oriented though. Maybe. It might be more mousy. Doesn't the multi-core rendering screw up your timing? Or wait, I already answered that one. Can you briefly explain how it tracks how long it takes the frame to work and the render engine to work if rendering the debug is part of that work? So right now we don't have a way of eliminating that part of the work, right? We can actually do that because we render the debug in a separate pass. So we will actually be able to figure that out to a certain extent, right? If you take a look here, in fact, we can already do it. This right here is the debug render group rendering, right? So if we wanted to know how long that was taking, we could do that. So yeah. So if you take a look here, it's like, okay, well, the debug rendering is taking a lot of the time. Because this is inclusive, right? This game update and render is inclusive. So basically, debug rendering is taking almost all of our frame time at the moment. You know, what are you going to do? So there's that. Part of that is, again, because it's probably doing the rectangle, and also it's got to blit all those little font things in there. So we're going to probably want to discount, you know, take that out of the equation when we're actually trying to do timing stuff. Because that's just, yeah, I mean, there's not that whole much we're going to be able to do about it. I mean, we can also double check to see how bad it is if we actually do an optimized build. Right now we're not, right? So if I optimize some of that, I don't know, but it's still going to be a problem, you know, no matter what we do. But yeah. So you can see that right now the debug rendering is still taking about half the time, but you can also see that we totally hit our frame rate just fine. So now we're like nice and locked at 30 hertz. But you can see though we wouldn't make 60 hertz with the debug rendering on. We would make 60 hertz with the debug rendering off easily, but with it on we wouldn't at all. And so it might be something where we want to try and discount that a little bit so that we know that when we're looking at the debug, it doesn't skew our timing stuff too much. But you know, again, we'll get there. We'll get there. Orlando Bloom, did you get 4Coder set up? No, I'm gonna do it on stream. So you know, I'm gonna reserve like doing the key mapping to on stream. So like when I get home early enough to do a longer pre-stream, I'm gonna do the bindings there, so people can see. Kitchism. Do you ever think it's amazing how hundreds of designers can screw up a project by trying to be complex when indie designers can make a better game in a few months? I mean, I don't know. I'm not really a game designer, so I don't really have too much of an opinion on that, but I would point out that like that's a little bit unfair, because if you're actually talking about indie games as a whole, there are a lot of really poorly designed indie games as well. I mean, there's like thousands of indie games that came out this year. 90% of them are probably abhorrently awful, right? But when you think of, when you say indie designer make a better game in a few months, you're talking about out of all of those designs, the few that were good, or maybe the designer was really good, or they just lucked out and the game was good, who knows, right? And you're comparing those against this big AAA game or whatever that you're saying it was screwed up or something, right? And that's a little bit unfair, right? Because there's only a few AAA games. There's not that many released every year, right? And so it's tempting to look at indie games and say, oh, there was like 20 indie games this year and they were all better than, you know, I don't know what, Arkham City or Asylum, Arkham Knight, Batman runs around, whatever. I don't even know. Metal Gear Solid 12. The Legend of Zelda boat riding simulation, right? Whatever it is. And you think that maybe the design was like overcomplicated or wasn't as good as this thing. It's like, well, yeah, but, you know, it's such a high stakes game and there's so few of them that it's actually very likely that, you know, it's not going to come out that well, just like it's very likely that most indie games are not going to come out well. But because of the numbers game, you know, that's not so much what happens. Plus, since there's no weight, indie games don't have a lot of weight to throw around. They don't, like, if you want to revamp something in an indie game, it's very easy oftentimes. You want to revamp something in a AAA game, you may be invalidating, you know, hundreds of millions of dollars worth of work. You can't just change something last minute. It doesn't work that way because there's so much like there's so much pipeline to the art production and all these other things. So yeah, you know, am I going to defend AAA games? Not necessarily, but I just want to point out that there's a lot of subtlety to that if you actually think about it. And it's not as simple as like, oh, AAA game designers are bad at their job. That may also be the case sometimes, or even often. But don't assume that it's always that. It's not a level playing field when you compare those two things. They're very different. And so, you know, it's complicated. Griggs, you mentioned that the way you draw Rex is not optimized. What do you want to change? So we optimized our texture filling, arbitrary scaling and rotating stuff. We optimized all that because we had to, and so that runs really nice and fast now. But we never wrote an optimized version of the actual just draw rectangle without any blip, just filled rectangle, right? So it's not even doing 4 pixels at a time. It's not even SIMD, right? So we could probably speed up draw a rectangle pretty dramatically, right? We could probably, I would imagine, speed it up quite a bit if we just did SIMD. Would we get 4 times faster? I don't know, but we could probably get quite a bit faster. Stephen last, because you're using rendering on multiple threads, is it saying that you're spending more cycles in draw rectangle quickly than game update and render? Well, no. So, okay. Again, you have to understand like what our timers are actually timing here, right? Oh, okay. I'm sorry. You know what? I misunderstood your question. I understand what you're asking now. Yes. Yes is the answer. So what happens here is game update and render is doing 1 thread's worth of rendering and then also waiting until all the other render threads are done. That's how that works, right? And so the other render threads are actually going to sum up the total amount of time that they all spent on their separate cores, right? So if we're running on 4 cores at the same time or whatever, I think we might even be running on 6 cores at the same time right now. I don't remember what we said to. 8? It's something high. They're going to be that many more times longer because each of them, is counting that full parallel part of time. So when you have 8 things running in parallel, we're going to get 8 times the amount of cycles spent in that period of time. And so if I understand the way you're asking the question, I got confused at first. The answer to what you're saying is yes. That is why. Why are you echoing to lock.temp in your batch file? The reason we echo to lock.temp in the batch file is for this code reloading stuff, which, by the way, we have to enable for the debug system. Right now, I'm pretty sure the debug system still doesn't actually work with that stuff, which we can fix, so we should. So what we do when we need to reload the game, we use this locking mechanism. Because Visual C++, I seem to recall, has some issues with loading the debug symbols or something like this. So what we did is we made sure that when we do Win32 load game code, we check to make sure that the lock file is not there. If the lock file's there, we won't try to do the load. So we won't try to load something where the debug info hasn't been written out yet. Because what was happening, if I remember correctly, is we would reload the game DLL as soon as it was ready. And the PDB, like the debug info, hadn't been finished. It wasn't finished writing. Like Visual C's compiler hadn't finished writing the debug info. So we'd load the new DLL. Microsoft Visual Studio would go, oh, a new DLL was loaded in. I'm going to go load the debug symbols for it. But it couldn't load the debug symbols because they weren't written yet. So having that lock file there just allows us to know, oh, the compilation's not done yet. Don't reload the DLL. Wait till it's done, because otherwise Visual Studio will poop out. JF Catalan. So after Lib Freedom Week, we could reasonably easily boot HH off something like bare metal OS and go all lookma no OS. Minus sound, I guess. Well, I mean, not really. It would depend on whether that bare metal OS had initialization code for like the graphics subsystem, right? Because we need, we prepare the bitmaps and the sound, but we need ways to hand that off to the hardware. So I don't know anything about bare metal OS, but you know, if it didn't have those things, you'd have to write like the graphics card driver and the sound card driver yourself, and stuff like that. So there might actually be a significant amount of work in there, and also like keyboard reading, that sort of stuff. So I don't know what bare metal OS is, but you know. Will Handmade Hero be optimized for GPUs, or are you sticking to CPU render? Will that be an arduous task or pretty straightforward? It won't be arduous. I don't know if it's straightforward, but it's not arduous. And I don't know to what extent we will optimize for GPUs. That remains to be seen. If I have a simple app concept that I can't code myself because I'm a scrub, is there any good way to get somebody to make an app for me that is somewhat simplistic and we split profits, or even I just get 10%? I don't care about the profits, I just want to help develop the app. Well, I would say this is the wrong stream to ask that. Obviously, this is a stream for people who want to do serious programming themselves. So I have no idea. Possibly. But, yeah, pretty far out of the topic of this show. Why are you not using Visual Studio to write your code? It seems to be a Windows machine you're working on. I don't like Visual Studio's editor. So it's the debugger. I mean, we do use the debugger. It's the best debugger on Windows that I know of. So we use that, but I don't like it as a code editor, so I don't use it. All right. We all good? I think that's it, folks. I think that is it. So I'm going to go ahead and close out of here, right? Okay, everyone, thanks very much for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along with the series at home, you can always pre-order the game on handmadehero.org, and it comes with the source code, even right now, so you can follow along even when we're just building the engine. And we added a new feature this week that people have been requesting for a while. So in addition to downloading zip files of the source for every day, we also now have a GitHub repository. And so if you would like to use GitHub to access the Handmade Hero source code, when you pre-order, there will be an access code that you can use and an instructional text file. So on that send owl, if you pre-order, you'll get a page that you can use to download Handmade Hero, the art assets, all that stuff. There's also a GitHub now, and there'll be an access code for your GitHub that you can use to authorize your username on GitHub. And so look for that. If you're someone who already pre-ordered the source code, if you go back to your send owl page, right? And if you don't know where that is, you can always do this. You can take the email address you used for the order and put it in this have it resent thing. You can go back to your send owl page, and there will be a new, it will have added at the bottom a access code and the text file with the instructions on how to authorize yourself. So if GitHub is something that you've been asking for or that you want to use to stay in sync with the source code, you can now get on those private repositories just by putting your username into that authorization system. So that's another option for you as well. As always, we also have a Patreon if you want to support the video series. We also have a forum site that you can go to ask questions, get people who have done ports to Mac and Linux, stuff like that. And by the way, those ports to Mac and Linux are now also in the GitHub that people are working on. So you can get those either from the forum site, or probably the GitHub's the right place to do that now. You can check our tweet bot, which tweets the schedule. So if you want to catch the series live, and if you do want to catch the series live, I think the next one will be Monday, probably 5 p.m., but I don't know. So check the tweet bot, because I'm not sure what next week's schedule is going to be. The Cinerama is running a movie series that has a lot of movies that I want to go see again. And so I may have to move, the stream may have to be moved to weird times next week. So check the tweet bot because I'm going to try and catch a few movies next week. Anyway, that's it for this week in Handmade Hero. We will be back next week to do some more programming. And I don't know if we're going to do, like I said, I kind of started getting... I'm kind of into that little display we made at the bottom there, so we may do another week of debug display coding before we do the lib stuff, because we didn't really go further down into the printing out of stuff area. So I may actually say let's do one more week of just debug printout stuff, debug visualization stuff, and then maybe we'll go do the lib stuff. So who knows? We'll see. But anyway, I hope to see you back here for that. Until then, have a great weekend programming. And I will see you guys on the internet. Take it easy, everyone.